hopefully that's, yeah, it says it's recording. All I've been able to sort of come up with is uploading it to my YouTube channel, which sounds a lot fancier than it really is. It'll be the only video there, so, but it was the only way I could think of putting the video on the web so that people could stream it rather than having to download the whole damn thing. Oh my god. That's going to be because of the video aspect. You can, I think it's a maximum of 25 people in the channel. I got the same answer, but I went about it in a slightly different way, I think. Or did I? Trying to work out from my scribbles what I did here. No, I did the same. I said it was 3,157 watts times. I said 3,157 watts times 3,600 seconds to give the answer in joules. And then what did I do? And then I completely ignored that. And what I did was I said it was 625,000 odd joules divided by 3166 joules, and that gave me my 198. That's the number of joules in a watt. One watt is 3,166 joules per second. So yeah, so I just I divided the number of joules that they tell you in the question by that, and it gave me 197.6. So yeah, so I did. So it looks like I did it a slightly different way, but whether I got the right answer by luck or is neither here nor there. Yeah, again, I got the same answer, different way. Just the beauty of physics. Yeah, what I did this time round was I said, okay, so it costs 12.6 cents for 1 kilowatt per hour, 1 kilowatt hour. So if you want, what we want is 3.157 kilowatts over, you know, the 198 sort of seconds that we're using it for. So I first of all I did 1 kilowatt over 1 hour, sort of divided by 1 hour. That equals 12.6. So that's 1 kilowatt over 3,600 seconds. But we want 3.157 over 3,600 and then times it by 12.6, and it gives you a fly in your face. It gives you the exactly the same answer, because you then sort of multiplying it by the number of seconds, which we worked out in the first one. So again, it gave me 2.2 cents. Same answer, different way. I did it again a different way, of course. Well, a slightly different answer. I, I I love my watts. It seems I again went with the watt being 1 joule per second. So 1 watt is 1 joule per second. So again, write it out as a fraction. So 1 joule over 1 second, and we're actually using 1.49 blah 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 times 10 to the 20 joules over a year, which is the 365 times 24 times 60 times 60 to give you the number of seconds. So then it's just a straight division sum. It's just 1.49391 times 10 to the 20 divided by 3,153,000 or something seconds, and that gives you the answer in watts. Yeah. I mean, well yeah, a watt is a per something, yeah. Um, but it was, yeah, it comes out to be a large number, times 10 to the 12. So, um, yeah. Yeah, yeah, yeah. One panel gives you 1,400 watts. You've got that sort of huge number of watts there. You just want to know how many times 1,400 fits into that huge number. It comes out with another huge number, which I didn't put into scientific notation. I just bashed it straight into the answer field as it was, and it was happy with that. So well, what I did for that, I thought, right, okay, if what I did was I said to myself, okay, so if a panel is 100% efficient, it provides 1,400 watts. So what's 15% of 1,400? So I worked out what 15% of 1,400 was, and that gives you the figure that you need then to divide into the answer that you got again. So instead of your answer divided by 1,400, it's your answer divided by 15% of 1,400. So that gives you the number of panels that you'll need at that lower efficiency. Yeah, and that one I did put into scientific notation because that was a very large number. I cheated. I hired myself off to the internet, and I found a formula which will give you the radius given all the numbers that you're given there. So so I epitomise the work smarter, not harder there. Okay, so the formula I got was R equals big square bracket 3 times m, that's the mass, over 4 pi, open brackets, density of air minus density of helium, close brackets, close big square brackets, and that is all to the power of 1/3. So just plug the numbers into that and you get the answer. I mean, where I got the formula from, there was a lot of well, you need to you can work out this bit from this formula, and you can work out this bit from this formula, and you mash the two together and you get so yeah. I mean, when you look at the equation, you can understand. I can understand the the density of air minus the density of helium, because the whatever area, whatever volume this balloon occupies, it's got helium inside it. So you're replacing the air that would be inside it with helium. So I can get that it's air minus helium. The Yeah, and the 4 pi, the sort of the 4 pi and the everything to the third is all to do with how you work out the volume of a sphere. So I understand all of that as well. So I can sort of pick the equation apart and understand it. It's just that I would never have been able to gather all the pieces together and put them together and get that answer. So yeah, so like I say, I cheated, but I can sleep at night. So I'm happy with that. Yeah. So I mean, the first question 7 there was just a bit of a sort of a gimme, because it was just the question gives you 650 centimeters cubed, and it asks it for in meters cubed. Um, Again, I don't work particularly hard when it comes to things like that. I go straight to a conversion website and say, uh, yeah, okay. Well, again, I didn't. I think in terms of, okay, so you know, if you've got 100% of the volume of the block, and it's 900 kilograms per meter cubed, so it's 900 kilograms at the top and 1 meter cubed at the bottom, and what we've got is sort of you just work that out to give you the no, hang on, what did I do here? This is one where it asks you for 80% of, what's it up? Because what's the question? It's because I've not done my notes particularly. What's the mass of the block? Oh right, yeah. So yeah. Yeah, you see, I've got that here as well, but I've not got my little asterisk next to it, which means that that's the answer I'm going to put in. I've got my asterisk somewhere else, so on a different answer. So, where's my calculator? Nope, don't know. I don't know how I got that answer. I mean, I got the 0.585 kilograms per centimetre cubed as that's obviously the density, and then density is mass times volume. So it's going to be mass. What was the? It was 900. No. Oh, right, so then it'd be 900 equals, no. Well, we were given the volume of the block. We, well, it's not. No, that's the density. That's the density in kilograms per centimetre cubed. It is, of course. Just having a look at the yeah, the 0.585 is the density of the block. Yeah. Yeah. Once you know the density of the block, then you can work out, because we know the volume. We're given the volume. I need a pencil. Right. So, I mean, the density equals mass times volume. Right. We know the density. That's the 0.585. Because it is how do we know? How did I work out that the density was 0.585? No, the density isn't. I just can't see where I've got this 0.585 from. It's Yeah, I mean, I worked out what 80% of the block is, because that's which I worked out to 520 centimeters cubed. Um, but I'm still. Ah, right, okay. Well, if you use the fact that, yeah, yeah, what we start off with is the 900 over a million. That's the density of the liquid. That's the 900 kilograms per meter cubed. Um, if we sort of knock off all the zeros that we don't like off the end there, um, just it could be 9 over. Yeah. Okay, and then we multiply that by 80% of the block. So 9 divided by 1, 0, 1, 2, 3 equals that. Times it by 0.00052. So I can see where that's coming from. Yeah, that's no. Just 9 divided by 1, 1, 2, 3, 1, 2, 3 equals that times 520. Yeah, that's the thing that's giving me the weight of the block, the 0.468 kilograms. Once you know the weight of the block, which is yeah, it's still not. Well, I found a question which right. So there's a question here which says a block of wood with the dimensions of blah 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 floats along the river with the broadest face facing down. The wood is submerged to a height of so many meters. What is the mass of the piece of wood? And it gives you the density of the water. So we've got the same. This question gives us the same things that we've got in this example. Yeah, well, I mean, we're told the volume. You just have to work out the volume in this one. So it's sort of, it's neither here nor there. Right. So what Jane did here was she worked out the volume of the water that was displaced by the block. So we need to work out the volume of this liquid that's displaced, which it's the 80% we're told. So that's the volume there is going to be 520 centimeters cubed. Yeah. So once we've got that volume, clean piece of paper. Right. So the volume is 0.00052 meters cubed. Right. So density equals mass over volume. Excuse me. So mass equals density times the volume, which in this case is density is the 900. Yeah, density is the 900 times the volume, which is our 0.00052. And what does that give us? 0.00052. Yes, that gives us the mass. Okay, so yeah, so that's what we're doing there then. So first of all we work out what 80% of the block's volume is. Yeah, but obviously you need that in meters cubed. Then density equals mass over volume. It's the mass that we want, so we rearrange the formula. So mass equals density times volume. The density that we're told of this liquid is 900 kilograms per meter cubed, and the volume we've just worked out as 0.00052 meters cubed. So it's just 900 times 0.0000, which gives us the mass of the block. I obviously did all of that practically. I probably, when I did the question, I thought, oh yeah, that's easy, that's just that by that, and didn't bother writing down how I got the answer. I will slap myself later. What is the density of the block? Is the next one. Again, I work this out by sort of cheating. Well, if the block was 100% submerged, it would have the same density as the liquid, which is the number we're given. But it's not, it's 80% submerged. So I just took the number we're given and found out what 80% of that was. Yeah. Yeah. So no density times mass times volume or anything like that needed there. Yeah, well, force equals mass times acceleration. Easy one. Yeah, we've worked out the mass. We're given, well, everybody knows 9.8 meters per second squared by now. So, yeah. Even with our head scratching on. Yeah, that was the one we were scratching ahead of. That was the density of the 80% of the block. So the density of 80% of the volume of the block, which is 900 times whatever 80% of the block is that you've worked out in volume, and that's it. That's your answer. Yeah, I'll put this up on, as I say, on YouTube, so that anybody who's not been here can watch the stream and scream and say, oh, it's simple, why are you making it so difficult for yourselves? Oh God, skip this. See you, folks.